So we're 2020 question 1 in paper 1. So it says f of x is equal to x squared plus 5x plus p, where x is an element of OR, and p has to be between or including -3 up as far as 8, and p is an element of z. So we know that p is a whole number. It could be positive or negative. So there won't be halves or fractions or decimals or anything like that. Find the value of p for which x plus 3 is a factor. Now, if you've been watching all the videos, you'll have noticed that is a factor is a phrase that keeps coming up time and time again. Generally speaking, if it's the phrase is a factor, you do long division. And the rule is, if it is a factor, the remainder should be 0. So that's the method I'm going to use. There is a method so that when there's variations, we've practiced the same method time and time again. So I'm going to stick with is a factor means long division and no remainder. So how do I make x into x squared? I need x multiply back x by x, x. Now what I normally do is I change my signs across. So this becomes minus, this becomes minus. I drop down the next one, which is the plus p, and I start the process again. How can I multiply back? 2 by x, 2x. I change the signs across. So I change my sign minus, minus. They cancel. P minus 6. Now remember, we said if it is a factor, the remainder 0, which means p is 6. So when I move the 6 over, p is 6. Find the value of p for which f of x has roots which differ by 3. Now in this case, we don't know what the roots are, but we know that they differ by 3. Now you'll notice it's a part 2. So the starting quadratic is still relevant. So we're not leaving that behind because it's a part 2. Sometimes students get confused. Is it brand new? Is it related? It is related if it's a part number. So it's still part of A. Now, this time round, we need to figure out the value of P if the roots differ by 3. Now, I have no idea what the roots are. But I do know they differ by 3. So what I'm going to do is I'm going to write down the formula that we use for the sum of the roots. So we normally have x squared minus the sum of the roots x plus the product of the roots. Product meaning multiply. And that should give us the equation. Now, if they differ by 3, we can call one root, for example, alpha, and the other one alpha plus 3. Now, we don't know what the alpha is, but we know that they differ by 3. So essentially, what would normally go here is I would have the sum of the roots alpha plus 3, x, and then I'd have the product over here, which would be alpha times alpha plus 3. Now, when we look into this bracket here, I'll highlight it for us, that is supposed to be the sum of the roots. Now, according to the equation, 5 has to be the sum of the roots. So I hope it makes sense that, and we just be careful here with the sign, minus alpha plus 3 is supposed to be 5. So piecing that together, I get 2 alpha plus 3 equals 5. Now I'm going to have to deal with the minus. So minus 2 alpha minus 3 equals 5. I might move the 2 alpha over and move the 5 back. You don't have to do it that way, of course, but it's the way I'm used to doing it. So in other words, I figure out that alpha is minus 4. So minus 4 is one of my roots. Now, that suggests that the other root is alpha plus 3, so the other root must be minus 4 plus 3, which is minus 1. So now I have my 2 answers. So they've asked me for P. Well, what is P? P is supposed to be the product of the roots. So if I'll use my highlighter here, the P is supposed to come in at the end, which means P is the product, which means it's alpha multiplied by alpha plus 3. Well, we now know what alpha and alpha plus 3 are. We know that alpha is minus 4, and we know alpha plus 3 is minus 1. So if I multiply those together, I get 4. So in fact, P in this case is 4. So my two answers are my roots, but my actual final answer in terms of answering the question is find the value of P, and the value of P is 4. Okay, I might stop this video here and then continue in the next one.